Hello dear students, today we will derive expression for electrical conductivity of a semiconductor. This is the next derivation in semiconductors. So consider a semiconductor of area of cross section A, its area is A, in which current I is flowing. Let V be the velocity of electron. When I say current I is flowing, there will be rate of flow of electrons. So V is the velocity of those electrons whose flow constitutes the electric current. The electron move through a distance V in 1 second. As per assumption of free electron theory, a large number of free electrons flow freely through the semiconductor whose area of cross section is A. So when a current I is flowing, it means there will be many number of free electrons which will be flowing through the semiconductor whose area of cross section is A. Now let the volume swept by electrons per second, the total volume swept by the electrons per second is nothing but A into V, area of cross section and the velocity. If n be the number of electrons per unit volume, let n be the number of electrons per unit volume and E is the magnitude of electric charge on the electron, then n is number of free electrons, E is the charge of electron, then the charge flow per second can be given as Ne E into A into V. Ne number of free electrons, E is charge on electron, A is the area of cross section and V is the velocity. So this is the charge flow per second. Since charge flow per second is the current, so we know rate of flow of charges per second is nothing but it is the current. Therefore we can write it as current I is equals to Ne E A into V. Now therefore current density J is equals to current per unit area. J can be given as I divided by A. So to this I, when you divide it by A, you will be getting Ne E into V. That is our equation number 1. Now the electron mobility mu E is given by, electron mobility mu E is given by, mu E is equals to V divided by E. That is equation 2, where E is electric field. Mu E is equals to V divided by E, where E is the electric field. Now equation 1 becomes, in this equation 1 we will substitute V is equals to mu E into E. V we will substitute mu E into E. So it is going to be J is equals to Ne into E into mu E into E. So in place of V we have substituted mu E into E and made it as equation number 3. But Ohm's law is given by, Ohm's law in terms of the current density J can be given as sigma into E. That is J is equals to sigma into E. Make it as equation number 4. Now this is also current density and this is also current density. We are going to equate these two equations. Okay, so we'll see in the next part. If sigma E is the conductivity due to electrons, sigma E is the conductivity due to electrons in the semiconducting material, the Ohm's law becomes J is equals to sigma E into E. In place of sigma we have written sigma E, and then we are going to compare equation 3 and 5. The current Ohm's law in terms of current density and equation number 5 we will compare it and we will be getting sigma E is equals to Ne E into mu E, which is our equation number 6. Now for an intrinsic semiconductor, the number of electrons will be equal to number of holes, hence sigma H will be, yesterday we have discussed the intrinsic semiconductor, the number of electrons. The electrons will be always equals to the number of holes. Therefore similarly like sigma E we can write sigma H. Sigma H is equals to NH E into mu H. right? Thus the conductivity for an intrinsic semiconductor can be calculated as, we know that the conductivity for an intrinsic semiconductor is sigma is equals to sigma E plus sigma H. Conductivity due to electrons and the conductivity due to holes. So total conductivity is sum of these two. That is the reason we can write sigma E as this equation NE into mu E and sigma H as NH E into mu H. Now in this equation Ne is equals to NH. The number of electrons will be always equals to number of holes. In the conductivity for an intrinsic semiconductor is given by, so we know that Ne is equals to NH, that is this Ne is always equals to this NH, and therefore replacing these two we will write common as Ni. We will write it as Ni, and E is common, we will take it outside, so it will be mu E plus mu H. So we can write sigma is equals to Ni E into mu E plus mu H, where I is intrinsic carrier concentration, and this is the expression for the electrical conductivity of a intrinsic semiconductor. Okay, so thank you.